Hi, I'm Brandon.
I'm Nat.
And I'm Andrew.
And today we're going to be explaining conservation of momentum.
Momentum is defined by the letter P and is equal to mass times velocity.
Many historians believe that Newton is the one who came up with the rule for conservation of momentum. Conservation of momentum is if no external forces are exerted on a system, the momentum is conserved.
Conservation of momentum can be used to explain how objects behave before and after collisions. The types of collisions are elastic, where kinetic energy is conserved, inelastic, where kinetic energy is lost, and explosions, where kinetic energy is gained.
Collisions are very rarely ever perfectly elastic or perfectly inelastic. First, we will explain why there needs to be no external forces for momentum to be conserved.
As you can see, the white ball was initially at rest, and after an external force was applied, it gained momentum.
Go.
Let's look at some examples of elastic collisions.
Before the collision, both balls are traveling at the same speed. After the collision, the white ball is traveling faster and the blue ball is traveling slower. This makes sense because the blue ball has more mass than the white ball does. Since the blue ball has more mass, the net momentum of the system must be to the left. For momentum to be conserved, the net momentum of the system must also be to the left after the collision. For that to happen, the velocity of the white ball must increase a lot, and the velocity of the blue ball must decrease a little.
The same logic can be applied in the next scenario.
Let's look at an example of an inelastic collision. Before, the ball moves very quickly, but after, the combined mass of the ball and the mote moves very slowly. This makes sense using the equation of conservation of momentum, which is m1v1 equals m2v2. As the mass goes up, the velocity must go down.
Next, let's look at some explosions. Momentum is conserved in explosions also. If you added up all the x components and y components of the velocities of every fragment and the mass, the result would be zero.
Not there.
Momentum is equal to mass. Momentum is equal to mass velocity. Momentum is defined by the letter P, which is equal to mass
And
times
is equal
velocity.
to.
Momentum is defined by the character P being equal to.
Freaking idiot!
Momentum is defined by the letter P, which is equal to.
Latin letter.
No.
Alright, let's do this. Let's do. We should probably restart this.
Action.
I wasn't even looking. The collisions are elastic, inelastic, and explosions.